In this video, we are going to see the hydroelectric power station tutorials problems. Into the last video, we solved the steam power station tutorials problem. So today we are going to see the hydroelectric power station. So the first question says a hydroelectric station has an average available lead of 100 meters and a reservoir capacity of 50 million cubic meters. Calculate the total energy in kilowatt hour that can generate, assuming the hydraulic efficiency of 85% and electrical efficiency of 90%. So the answer is given. So let's see whether we are going to find the answer. So I am to calculate the total energy that is generated. So let me figure out the data. I am given my height as what? As 100 meter, and also I am given my V as what? As 50 million. Let me say times 10 raised to the power of 6 what? Meter cube. And also I am given the hydraulic efficiency. The hydraulic efficiency, it is the same thing as convert it 85%, it will now become 0.5%. And also I have the electrical efficiency. So let me say it is equals to 0.90. And therefore you have to take note that my overall efficiency, let me say the overall efficiency will now be equals to 0.85 multiplied by what? Multiplied by 0.90. So the overall efficiency will now be equals to 0.76 what? 765. So the first thing that I'm going to do, I'm going to find the energy that is what? Energy that is available. So the energy available, it is what? The formula that I'm going to use is energy is the same thing as what? As rho GH V and what? And the efficiency. So this E will now be equals to, I would say, the density, which is 1000, which is the density of water, and multiplied by the gram, which is 9.81. and also multiply by what? By the height, which is 100, and also multiply by the 50 million times 10 raised to the power of what? Of 6, and also multiply by the overall, which is 0.765. So at the end, what should I go into get? So at the end, I'll get my E should now be equals to 3.7 what? 752 3 times 10 raised to the power of what? Of 13 joules. So I have to convert this to what? To kilowatt, because it says calculate the total energy in kilowatt hour. So to convert this in kilowatt hour, let me have some space. I'll first say that the energy, it is the same thing as the 3.752 times 10 raised to the power of what? Of 13 divided by what? Divided by 3.6 times what? Times 10 raised to the power of what? Raised to the power of what? Of 6. And therefore it will now be equals to what? 1.042 times 10 raised to the power of what? Of 7. So therefore the final answer will now be equals to 10.42 what? 10.42 million kilowatt hour as what? As the final solution to what? To this first problem. So as you can see, our answer is what? Is the same as what they give. So you have to take note that after inserting the formula, so you have to first convert it to what? To kilowatt hour. To convert it to kilowatt hour, so you are going to divide 3.6 times what? Times 10 raised to the power of what? 10 raised to the power of what? Of 6. So the next question says, calculate the continuous power that will be available from hydroelectric plants having an available heat of 300 meters, catchment area of 150 square kilometer, annual rainfall of 1.25, and yield factor of what? Of 50%. Assume the penstock turbine and generator efficiency to be 96%, 86%, and 97% respectively. So if the load factor is what? The load factor, it is 40%. So then what should be the rating of the generators installed? So you have to take note of this. The first thing that I'm going to do is that I have to first find the annual water that is available. So now if I'm to find the annual water that is available, so I'll say the volume be equals to what? Should now be equals to 150 times 10 raised to the power of what? Raised to the power of 6, which is what? Which is 150 kilometer, which is the area. So I'll say 150 times what? Times 10 raised to the power of what? Raised to the power of 6, and multiply by what? Multiply by the rainfall, which is 1.25 meter. So I will say 1.25 meter, and also multiply by this yield factor 50%, so it will now become 0.5. So I will say 0.5. So if I say 150, the annual water that is available, times 1.25 times 0.5. So at the end, I'll get 90 what? 93.75 times 10 raised to the power of what? Of 6. But let me put it here. So my new V, it is what? It is 93.7 what? 75 times 10 raised to the power of what? Of 6 meter cube. So I've already find the value of what? The value of my V. So the next thing, I'm going to find the flow rate. So the flow rate, I will say the volume divided by what? Divided by the number of what? Number of days in a day. Okay, sorry, number of days in a, and also number of the hours in what? In one day, and also second in 1 hour. So I will say 93.75 times what? Times 10 to the power of 6 divided by what? Divided by this in what? In 1 year, and therefore multiply by hours in what? In a day, and multiply by what? By second in an hour. So my Q also will now be equals to, which is the flow rate. So it will now become 2.97 what? Meter per second as what? As my flow rate. So the next thing that I'm going to do, I'm going to find the overall efficiency. My overall efficiency will now be equals to, I have the efficiency, I have 96%, 86%, and 97%. So I will say 0.96 multiplied by what? Multiplied by 0.86, and also multiplied by 0.97. At the end, I will get 0.801 as what? As my overall efficiency. So I have to say the overall efficiency, it is 0.801. So the next thing that I'm going to do, I'm going to find my what? My continuous what? My continuous power. So what is the formula of the continuous power? You have to take note that the question says we are to find the continuous power. So the formula for the continuous power is what? Is P, it is the same thing as rho G Q H and what? And the overall efficiency. So that's the reason I first find my V, and also find my Q, and also find my overall efficiency. To find the the flow rate, I must to find the value of P. So that's why we find the value of our V first. So this should now be equals to density, which is 1000, and also 9.81 as what as our gram, and also our flow rate, which is 2.97, and also the value of H. What is our H? The value of H, which is what? Which is 300. And also we have the value of what? Our overall efficiency. So I will say multiplied by what? Also multiplied by 0.801. So at the end, the value of my P should now be equals to so it will now become 7.0 times 10 raised to the power of what? Raised to the power of 6 watt. So the next thing that I'm going to find is the generator rating. The question says, what should be the rating of the generator installed? So we have to find two things. We first find what the continuous power. The next thing we are going to find the generator rating. So to find any generator rating, it is the same thing as saying 7.0 divided by what? Divided by the load factor. So we have to take a look and see where is the load factor. So don't forget we have load factor here as 40%. So I will say it will now become 0.4 after conversion. So the generator rating, it will now be 17.5 megawatt. So this is the solution of what of this question. As you can see, we find 7.0 times 10 to the power of what of 6. And from what they find, it is almost the same thing to 70. This is in what? This is in mega, and this is in what? Kilo. So it is all the same thing. And the next we find 17.5. They find 17,662 kilowatt, but our one is in megawatt. So it is almost the same thing. You can convert it to what? To this kilowatt. The next question says, a hydroelectric plant has a reservoir of area 2 squared kilometers and the capacity 5 million cubic meter. The net head of water at turbine is 50 meter. If the efficiencies of turbine and generator are 85% and 95% respectively, calculate the total energy in what? In kilowatt hour that can be generated from what? From this station. If a load of 15,000 has been supplied for 4 hours, so we have to find the rainfall in a reservoir. So the first thing that we are going to do here is that we have to first find the overall efficiency so that we can find the energy. The energy's formula, as usual, it is rho G H, and then we have what? And then we have the capacity, which is what? Which is the volume, and then multiply by what? By the efficiency. So this will now be equals to, I have 1000 as my density, and also multiply by 9.81 as my gram, and also multiply by the height, which is 50, and also multiply by what? By the V, which is 5 times 10 raised to the power of what? Of 6. So you have to take note, this is my height, and also this is what? This is maybe 5 million cubic meter. And also I have to say multiply by the overall efficiency. My overall efficiency will be, I have 85% and 95%. So I will say 0.8 what? 85, and also multiply by what? 0.95, and I'll get 0.8 what? 8075. So it will be 0.80775. So what should I get as my energy? So my energy should now be equals to what? 1.980 times 10 raised to the power of what? Of 12 joule. So the next thing that I'm going to do is that I have to convert it. As usual, if we are going to convert this joule to kilowatt, we are going to divide it by what? By 3.6 what times 10 raised to the power of what? Raised to the power of 6. So therefore my new E should now be equals to what? 5. After dividing it, 5.0 times what? Times 10 raised to the power of 5 what? Kilowatt hour. So this is what? This is my energy. So you have to take note that for a load of 15 kilowatt for 4 hours, the energy supplied will now be equals to what? Will now be 15,000 multiplied by what? Multiplied by 4, which will be equals to what? Will be equals to 60,000 kilowatt hour. So therefore the water volume used will be equals to the 60,000 multiplied by what? By this 3.6. So 3.6 times what? Times 10 raised to the power of what? Raised to the power of 6, and also divided by what? Divided by the 1000, and then multiplied by 9.81 and multiplied by 50, and also multiplied by the overall efficiency 0.875. So you have to take note that I make the value of what? Of my B to be the subject of the formula, so that I will find the water volume what? Use in that 4 hours. So therefore at the end my V should now be equals to, my V, it will be equals to 5.45 times 10 raised to the power of what? Of 5 meter cube. So this is what? This is the volume. Therefore we are asked to find the fall in reservoir. So how can we find the fall in reservoir? To find the fall in reservoir, I would say the H is the same thing as what? V over what? Over E. So therefore it will now become, my V, it is what? It is 5.45 multiplied by what? By 10 raised to the power of what? Of 5 divided by the area, which is 2 times what? Times 10 raised to the power of what? Of 6. This is what? This is the area. You have to take note of that. So therefore at the end it should now be equals to my height, which is 0.273 meter. So as you can see, this is in meter. So if you convert it to centimeter, you are going to get almost this 27 point something. And don't forget, this is what? This is our energy, and also we find it correct. So let's move to the next question. It has been estimated that a minimum runoff of approximately 94 meter cube per second will be available at a hydraulic project with what? With a head of 39 m. So we are to determine the firm capacity and yearly what? Gross output. So you have to take note that we are going to first find the firm capacity. So therefore this P will now be equals to rho G Q what? QH, and it is the same thing as what? As we all know, 1000 multiplied by 9.81, and also multiplied by what? Multiplied by 94, and also multiplied by what? Multiplied by 39, which is the what? Which is the height, 39 meter. So at the end I will say 1000 multiplied by 0.81, and I'm also multiplied by what? By 94. And you have to take note that this 94 is what? Is our flow rate, which is Q. So this will now be equals to 3.60 times what? Times 10 to the power of what? Of 7 watts. So therefore our P, it is the same thing as what? As 36 megawatt. So the next thing that I'm going to do, I'm going to find the yearly output. It says the yearly gross output. Yearly gross output will now be equals to E. I will say the 36 megawatt, I will multiply by what? By 8,700 and what? 760. So therefore this will now be equals to 3.15 times 10 raised to the power of 8 kilowatt hour. So this is what? This is a yearly output. For those of you that doesn't know the 8,760, should check back my video whereby I explain this 8,760 and how you can use it in steam power station. So check the description of this video for the full lecture of it. So therefore we are done with this question. So as you can see, we find 36 megawatt and we have 3.5. So this is kilowatt, and also this is 10 to the power of 8 and this is 10 to the power of 6, so it is all the same thing. And we have 36 megawatt, we have 3,600 kilowatts, so it is also the same thing. A hydroelectric power station is supplied from a reservoir having area of 50 kilometers square and a head of 50 meters. If overall efficiency of the plant is 60 seconds, find the rate at which the water level falls when the station is generating as 30,000 kilowatts. So how can we find the rate? So the first thing that you are going to do here is that, so I'm going to first find the flow rate. So what will be my flow rate? The flow rate will be 30 times 10 raised to the power of 6, and also divided by divided by 1000, and also multiplied by by 0.81, and also times 50, and also times times my overall efficiency. So I am having only one efficiency, so which is 0.6. so you have to take note that all we are using this formula that says rho G H, rho GQ H, and and the efficiency. So we are using this formula. So you have to take note of this. So all the way you are going to make this Q subset of the formula by dividing both sides by rho G H and the efficiency, also rho G H and the efficiency. This will go with this. You are left with only Q, which is the same thing as P, which is the power, by rho G H and the efficiency. As you can see, this is rho, and also this is the gram, and also this is the height, and also this is the efficiency, and this is also the efficiency. But sorry, this efficiency, it is 0.6. So you have to take note of this. So the next thing that I'm going to do here is that, so after this I'm going to find the rate of fall. The rate of fall, I will say DH by change in T. Also it is the same thing as as Q by Q by by A. Okay, sorry, I didn't find the solution of this. Let me solve. 30 times 10 to the power of 6 divided by times 9.8 times 0.6. So at the end my flow rate will be 102 meter cube per second. So I will now say the flow rate, it is equals to 102 divided by area 50 times times 10 raised to the power of raised to the power of 6. So therefore, let me see, answer divided by 50 times 10 raised to the power of 6. So it will now be equals to 2.04 times 10 raised to the power of of negative 6 meter per second. So the next thing that I'm going to convert this to meter powered per hour. Converted to meter per hour, it will now become 0.0735 meter per hour. And also, if I'm to convert it to millimeter, not meter, what should I going to get? Let me say I should multiply it by multiplied by 1. So it will now be, let me have some space. So it will now be equals to 7.35 millimeter per watt per hour. So this is the final solution, and also they find 7.337 millimeter per hour. So it is all the same thing. Hope you all know how to convert this meter per second to hour, and also convert this meter per hour to millimeter per watt per hour. So let's move to the number 6. A hydroelectric plant has a catchment area of 120 square kilometer. The available runoff is 50% with annual rainfall of 100 centimeters. A head of 250 meters is available on the average. Efficiency of the power plant is 70%. So we have to find the average power reduced, the capacity of the plant. Assume the load factor is this. So the first thing that I'm going to do, what should I supposed to do first? I'm going to first find the annual runoff volume. So this volume will now be equals to 120 kilometer square. I will say times 10 raised to the power of 6, and also multiply by multiply by the rainfall, which is 100 centimeter. It is the same thing as 1 meter multiplied by 1, and also my runoff, which is 50%. Converting it will become 0.5. So at the end, my volume will now be 60 times times 10 raised to the power of 6 meter cube, because it is volume. So the next thing, I'm going to find my flow, the flow rate. So what will be the flow? I will say the 60 times times 10 raised to the power of 6 meter cube, and also divided by days in a year, and also multiply by days in a day. Hours in a day, and also multiply by second in 1 hour. So what should I going to get? I'll get, let me see. So I'll get 1.90 meter cube per second. So the next thing is the average power. What will be my average power? As you all know the formula of the average power, I'll say rho multiplied by by G, and also multiply by multiply by the Q, which is 1.90, and also multiply by multiply by our height. So you have to take note of that formula that says rho G Q H and and efficiency. So after the height, which is 250, then 0.7 as my efficiency. So at the end, let me see what should I going to get. So it will now be equals to 3.26 megawatt. So as you all know, it is the same thing as at this 3.26 megawatt. So what is the next thing that I'm going to do? The next thing, this is the average power that is produced, and the next thing is the capacity of the plant. If the load factor is 0.6, so what will be the capacity of the power plant? Let me have some space. So the capacity of the power plant will now be equals to what? I have to say the capacity, it should now be equals to the 3.26 divided by by the load factor, assuming the load factor is 0.6. So what should I going to get? Divided by 0.6. So at the end, I will get 5.43 megawatts. Yes, we are done. It is the same thing. So this is all I have for you for the tutorials problem under the hydroelectric power station. Don't forget to subscribe to this YouTube channel if the video is more helpful to you, and please comment, like, and share, and do share to your learning colleagues. Thanks you for watching, and do have a nice day.